Alright, so problem 53 is a nice little problem. Um, isn't immediately reminiscent of a collision problem because essentially a bullet goes through something, through a block, but that's technically a collision. In fact, it does collide inelastically with the second block because it sticks in the second block, right? But you may not think the interaction with the first block is a collision, but it is. So, first off, the mass of the bullet is tiny. .5 grams, which we should convert to kilograms. 0.0035 kilograms. The mass of block 1 is 1.2 kilograms. Mass of block 2 is 1.8 kilograms. We also know the blocks start at rest. V initial 1 equals V initial 2, which is 0 meters per second. Velocity 1 final is 0.63 meters per second, and velocity 2 final is 1.4 meters per second. We're trying to find the speed of the bullet. VB in a couple spots. So let's draw this real quick. Block here, block 1, block 2. The bullet goes straight through block 1, and then gets embedded into block 2, and then they both blocks will move a bit. So first off, let's do this interaction. We got mass of the bullet times velocity of the bullet initial. That's out here before it hits the block. That's an I. Plus, oops, mass of block 1 times velocity initial of block 1, which is 0, so that's going to go away. Mass of bullet times velocity of the bullet in the middle here, after it exits block 1, but it still hasn't hit block 2 yet, so in the middle of the two blocks, we'll say VBM, plus mass of block 1 times velocity 1 final velocity of block 1. Alright, 0.0035 times VB initial, we don't know that, plus 0 because V initial, oops. Oh, that's right. Don't do that, please. Gosh. Silly bug. Plus 0. Just write more carefully. Velocity initial 1 is 0, so this block's at rest, so that goes away. Plus 0.0035. And we don't know this speed either. Velocity of block in the middle plus mass of block 1 is over, oh gosh, 1 initial, velocity 1 final, equals. That's just 1.4, 1.63. Mass of block 1 is 12 kilograms. Velocity final of block 1 is 0.63 meters per second. Well, we got two unknowns here, so we can't go any farther. Let's do the second interaction, see if that helps us out. So down here we get M block, V block in the middle, because the second interaction takes place right before the bullet hits it, and then right after the bullet hits it. So that's VB middle, because it's the velocity of the bullet in the middle here. Plus M2 V2 initial, which is 0, equals MB. Oh, they stick together. So you just do MB plus M2 times velocity B2 final, which is really this. 0.0035 times VBM plus 0 equals 0.0035 plus what is it? 1.8. This is a point here. 1.2 plus 1.8 times the final velocity is 1.4. We can solve. We only have one variable here. We can solve for VBM. V bullet in the middle, the speed of the bullet in here happens to be 721.4 meters per second. You just solve all this for VBM. Take that VBM 721, stick it up in here, solve for this VBI, and you should get VBI equals 937.4 meters per second. It's some basic algebra that I won't need to do out for you. Yeah, so that's problem 53. We got a bullet block interaction where a bullet going through is sort of like a, well, I mean, it is a collision in a sense. Things don't necessarily bounce, but two objects collide and hit, and when that happens, momentum changes. And whenever that happens, you know that momentum is conserved always, 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 always. So we just used conservation of momentum twice. Alright, bye-bye.